Okay, here we go. Determining the equation of a line. On the grid shown, plot the point 4, 1. 4, 1. How many lines pass through the point 4, 1? Well, we could draw a line this way, so let's say infinitely many. Infinitely many lines pass through the point 4, 1. How many lines pass through the point 4, 1 with a slope of 3, 2? Well, if we do that, so 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, and I like to go both ways, so 1, 2, 3 down, and 2 left, 3 down, 2 left, 3 down, 2 left. I would say that there is only one line that passes through the line 4, 1 with a slope of 3, 2. On the grid shown, accurately draw the line, label the coordinates of as many points as you can. Okay, hang on, I'm going to move this down a bit. Okay, I think I have all the points. Let's draw the line. And line's got this. We got the point 4, 1. We got the point 6, 4. We got the point 8, 7. We got the point 10, 10. We've got the point 2, negative 2. We've got the point 0, negative 5. We got the point negative 2, negative 8. And can I get one more? What's the slope again? 1, 2, 3. No. So that's all we're going to see. Does this line pass through the point negative 4, negative 11? It kind of doesn't look like it. Because let's see, from here we would be going, which way are we going? We would be going down 3 and left 2. So yeah, actually it will. Just the line's not drawn very well. Negative 4, negative 11. So yes, use the slope formula to verify your answer. Okay, so we know that slope is y2 minus y1 over x2 minus x1. And I guess what we want to see, let's see if the point negative 411 with the point 41 gives us a slope of 3 over 2. Alright, what are we going to use? So let's start with negative 11 minus 1 over negative 4 minus negative 4, negative 4, equals negative 12. Oh wait, sorry, that should just be negative 4 minus 4. What did I start with? So negative 11 minus 1 and negative 4 minus 4, which is negative 8. And this is 3 over 2. So, check. Sam claims that the line that passes through 4, 1 with a slope of 3, 2 also passes through the point 14, 16. Use the slope formula to verify his claim. Okay, well we already wrote the formula out up here, so let's just go 16 minus 1, that'll be y2 minus y1, over 14 minus 4, which is 15 over 10, which is 3 over 2. So, yes, Sam, your claim is verified. The line that passes through 4, 1 with a slope of 3, 2, also 3 over 2, also passes through the point 20, comma y. Use the slope formula to determine the value of y. Okay, so in this case, we know the slope is 3 over 2. we're going to go with y2 minus y1, or y minus 1, over 20 minus 4. Gives us 3 over 2 is equal to y minus 1 over 16. We're going to cross multiply. 2 times y minus 1 equals 3 times 16. Let's go up here. So y 2y minus 1 equals 48. Y minus 1 is 24, so y is 25. So the point is 20, 25. If the line passes through the general point xy, use the slope formula to write an equation that relates xy to 4, 1. Okay, so remember slope formula. Let's just write it down again. x2 minus x1. Okay, we know the slope is 3 over 2. We're going to use this as y2, so y minus 1 over x minus 4. So that's the slope formula. Rearrange the equation so that y is isolated. Okay, so 3 times x minus 4 is equal to 2 times y minus 1. Let's go down here, we'll finish this off. 3x minus 12 equals 2y minus 2. 2y, that's the 2y, will equal 3x. And we're going to add 2 to both sides, so 3x minus 10, ultimately leading to y equals 3 halves x minus 5. So we have the equation, actually what we've just done is develop the equation of the line with a slope of 3, 2 passing through the point 4, 1. Enter this equation into your graphing calculator and verify this graph is the same one you drew. Use the second calc value feature or the table feature to verify the coordinates of the points you labeled on your hand drawing. Okay, so let's go back, and I'm going to pause and open. Okay, I'm back. We're going to graph y equals 3 halves x minus 5. So I'm going to hit graph. Oops, somehow second function was on. I guess we're in the table. But let's take a look then. We've got 0, negative 5. We've got negative 2, negative 8. We've got negative 4, negative 11. Let's scroll down the table and see if we have. So we have 2, negative 2. We have 4, 1. We have 6, 4. We have 8, 7. We have 10, 10. So all those points are in there. Let's actually graph it this time. And there's our graph, which matches up with the graph that we see there. So I think we've accomplished all of the things. Use your graph to verify it's the same as the one you drew. Yes. All right, need a pen back. Yes. Yes. Complete the following table if the general point P, X, Y lies on each of the following lines. Okay, so we have a line passing through a particular point with a given slope. Statement about the slope is that it's 5/3, and the equation is y minus 7 over x minus negative 2 equals 5/3. The slope of PB is negative 3/4, and our equation will be y minus negative 1 over x minus 6 is equal to negative 3/4. And you can actually put the negative on the top here or on the bottom, but to get a positive y, I'll put it up top if I cross multiply this after simplifying. We'll end up with a positive y and a negative x. So the slope of the line, the slope of PC is 4, or as I like to write it, 4 over 1. And we'll go y minus negative 8 over x minus negative 3 is equal to 4 over 1. Here. Okay, we have a point here. We have another point here. So the slope of our line is 1, 2, down 2, 1, 2, 3, 4, 5. So the slope of the line, and let's call this point D, I guess, and then, so the slope of the line is, what was it again? Down 2 over 5, negative 2/5. And the equation will be y minus 3 over x minus negative 2 is equal to negative 2/5. And that's what we're interested in there. For the line that passes through A, negative 2, 7, with a slope 5/3, we wrote the equation y minus 7 over x minus negative 2 equals 5/3. This equation is called the equation of the line. It is a statement that is true for every point on the line that passes through A, negative 2, 7, with slope 5/3. In order to find the equation of the line, we need to know two things. A point on the line, and the slope of the line. In general, if the general point P, xy, lies on the line that passes through the specific point A, x1, y1, with slope m, we know that the slope of PA is equal to m, and the equation of the line is y minus y1 over x minus x1. And that one there should be a little subscripty. And that's equal to m. Write the equation of the line that passes through A, negative 8, 3, with slope 1/4. Okay, so we're going y minus 3 over x minus negative 8 is equal to 1/4. Rearrange the equation so that y is isolated. So that'll be 4 times y minus 3 is equal to x plus 8. Okay, we get the 1 here, so then that's plus. So y minus 3 is equal to 1/4 x plus 2, and y is equal to 1/4 x plus 5. Okay, so just a little rearrangement, and there we go. Moving on down, there are several different forms of the equation of a line. So far you have seen two different forms. For example, the equation of a line could be y minus 3 over x minus negative 8 equals 1/4. But this equation could be rearranged into the very useful y equals 1/4 x plus 5. There are two other forms that are also useful. The equation can also be written as y minus 3 is 1/4 x plus 8, and x minus 4y plus 20 equals 0. The form y minus 3 over x minus negative 8 equals 1/4, which is the one we started with, does not have a name. The form y equals 1/4 x plus 5, useful for the graphing calculator, also for us graphing, is called the slope-intercept form. The form y minus 3 equals 1/4 x plus 8 is called the slope point form. Let's call this slope y-intercept. And the form x minus 4y plus 20 equals 0 is called the general form. So we have the slope y-intercept form, the slope point form, and the general form. Different forms are shown below. Note x1, y1 is a known point, right? That's the point that we know. That's the 3, 2 or the 5, 7. M is the slope of the line. B is a real number. And A, B, and C are integers where A is greater than 0. Okay, so that applies to everything in this table here. This one only has the A, B, C. This has M, this has M, this has M, this has x1, y1, this has x1, y1, and this just has B. Alright, let's do some examples. A line with a slope of negative 5/3 passes through negative 4, 7. Determine the equation of this line in each of the four forms. Okay, let's start with this, shall we? So y minus y1, which is 7, over x minus negative 4 is equal to negative 5/3. So that's our first form. To get slope-intercept form, let's multiply this out. So in this case, I'm going to go 3 times y minus 7 is equal to negative 5 times x plus 4. Let's just hang that 3 out for a second here. So 3y minus 7 equals negative 5x minus 20. Okay, let's get rid of the 3 now. So we'll multiply by 1/3. Y minus 7 is negative 5/3 x minus 20/3. Let's add 7. Now keep in mind 7 is 21/3. Negative 5/3 x plus 1/3. Okay, and this is slope y-intercept form. To get into general form, we can take the slope y-intercept form, multiply through by 3, giving me 3y is equal to negative 5x plus 1. What we're doing is we're multiplying by the lowest common denominator to clear out any denominators. We now need it arranged so everything's on one side. We want the a to be positive, so we're going to move the 5x over. Plus 3y minus 1 equals 0. And that gives us the general form equation, ax plus by plus c. And if I want slope point form, then we're going to go back to this unnamed form. Okay, and we're going to write, so from here, we're going to write y minus 7 is equal to negative 5/3 x plus 4. Okay, and that is the slope point form. This is the general form. This is the unnamed form. And this is the slope y-intercept form. Okay, so we have all 4 forms of the equation. Determine the equation of the line that passes through negative 119 and negative 513. Express your equation in the general form where a, b, and c are integers and a is greater than 0. Okay, let's pop back a bit. One thing that we'll find is, first of all, in order to get general form, it's going to come from one of these other forms, and each of these other forms requires me to know the slope. So let's start off by finding the slope of this line. So m is y2 minus y1 over x2 minus x1. Slope is, let's go 19 minus 13 over negative 1 minus negative 5. So 19 minus 13 is 6. Negative 1, this is b plus 5. So negative 1 plus 5 is 4. Reduced, slope is 3 over 2. Okay, well, I want to get into general form. So, excuse me, we could start with y minus y1 is equal to mx minus x1. So y minus, and now what we do is we pick one of the points. Doesn't matter which one. So let's go with the 19. Y minus 19 is 3/2 x minus negative 1. Y minus 19 is 3/2 x plus 1. Let's multiply through by 2 to clear out any denominator. 2y minus 38 is equal to 3 x plus 1. 2y minus 38 equals 3x plus 3. We need the x positive, so we're going to go 3x. We'll move the y over, minus 2y. We're going to move this over, adding 38 to both sides, so plus 41 is equal to 0. algebraically show that the point 7, negative 31 lies on this line. So here's general form. If we substitute the x and the y in, we should get a true statement. So 3x minus 2y plus 41 equals 0. And what we're doing is checking for the truth of this. So 21, this will be plus it's a minus 2 times that is 62 plus 41 equals 0. That's not going to work unless that's a minus. So what did I mess up? 7 for x, negative 31. Okay, hang on. Let's go back and look and see what we've got here. 19 minus 13 is 6. Negative 1 minus negative 5, which is negative 1 plus 5, which is 4. We get 6 over 4. What if we did it the other way? We'd have 13 minus 19, which would be negative 6, and we'd have negative 5 over negative 4. No, so that's still 6 over 4, or 3 over 2. Y minus y1 is mx minus x1. Y minus 19, 3 halves, x, plus 1. Y minus 19, multiply. 2y minus 38. 3 bracket x plus 1. 2y minus 38 is 3x plus 3. 3x minus 2y plus 41. Alright, so I'm wondering. Alright, let's take a further look at this. If I have the point negative 119, negative 119, and negative 513, in relative position, they're like this. So 7, negative 31. I can't have that. This line has a positive slope. So anyways, this point is not on the line. Not true. Not on line. What would the point? If we had a 7 there, then the point would be 7 and then some big number here. So we have verified that a point is not on the line. Alright, I think we got 2 more to do here. If the line 3x plus ky minus 16 equals 0 passes through, what if that was like negative 7? If that were negative 7, we get negative 21 plus 41 plus 62. No, still don't see it. If the line 3x plus ky minus 16 equals 0 passes through the point 8, negative 2, this might differ on your worksheet too, then algebraically determine the value of k. Alright, so this time 3 times 8 plus k times negative 2 minus 16 equals 0. This we can at least solve. 24 minus 2k minus 16 equals 0. Negative 2k plus 8 equals 0. Negative 2k is negative 8. So k is equal to 4. Alright, so that one's done. So again, if we're going to algebraically determine a point on a line or that, we're just substituting into the equation and verifying, or in this case, solving. A point and a line are shown. Draw the line that passes through point A and is perpendicular to the line shown. So that means I need the slope of this line, which is 1, 2, 3, 1, 2. So the slope is equal to negative 3 over 2. So a line perpendicular will be 2 over 3. So draw a line that has a slope of 2. 1, 2, 3. Up 2, can't go up 2, go down 2, 1, 2, and left 3, go down 2, and left 3. A nice try with the line. And that's close. It's easier to draw on paper, you realize. What are the slope and the y-intercept of this line? So the slope is, what did we say it was? 1, 2, down 2, and right 3, so negative 2/3, and luckily we can see it goes through that point, so the y-intercept is negative 4. The equation of the line in slope-intercept will be negative 2/3 x minus 4. That's easy, right? So that's it. Determine the equation of this line. I don't really know that we would determine so much as we would state. I guess the determining is that we're showing that the slope of this line, right, is negative 3/2, and the slope, oops, that's a positive 2/3. Positive 2/3 x minus 4. Examine your equation and answers in part B. Do you notice anything? Examine your equation. Oh, that the slope and the y-intercept are the slope and the y-intercept? No. So I guess for determine the equation of this line, maybe we want to do it with a couple of points. So here, let's go off and determine this. So the slope of the line, so m, what are we going to go with for the equation? So about y minus y1 is equal to mx minus x1. Y minus, okay, so we're going with the point, which is 3, -2, so y minus -2 is equal to m, which is 2/3, x minus 3. Y plus 2 is equal to 2/3, x minus 3. Multiply through by 3. 3y plus 6 is equal to 2, x minus 3. That's going to go, well, let's go 3y plus 6 equals 2x minus 6. 3y is equal to 2x minus 12. Okay, now if we want a general form, we just go 2x minus 3y minus 12 equals 0. We want slope-intercept. Divide through by 3, and we get 2/3 x minus 4. So there is the determining of using the slope and using the point on the line, which I didn't draw the line very well, but there's the equation. And what do we notice? That it's related to the slope and the y-intercept there. And that is all. And I really have to look at example 2b. So I'm just going to pause while I do that.